Welcome, students. Today, we embark on a journey to explore the fascinating world of motion in a straight line. This fundamental concept allows us to understand the motion of objects along a single dimension, such as a straight road or a ruler. Motion in a straight line can be described using a few key quantities. The first and most basic is position. The position of an object refers to its location along the line. We often choose a reference point called the origin, and we measure positions relative to this point. For example, if the origin is at one end of a ruler, we can say that an object is at position 5 centimeters or 10 centimeters from the origin. To understand how an object's position changes with time, we introduce the concept of displacement. Displacement is the change in an object's position between 2 points in time. It is a vector quantity, meaning it has both magnitude and direction. If an object moves from position A to position B, its displacement is the difference between the positions of B and A. Displacement is often represented by the symbol dx, where delta denotes change in, and x represents the position. Now, let's talk about the concept of distance and how it relates to displacement. Distance is a scalar quantity that refers to the total length traveled by an object, irrespective of its direction. Unlike displacement, distance is always positive and does not consider the direction of motion. For example, if you walk 10 meters forward and then 10 meters backward, your displacement is 0, but your total distance traveled is 20 meters. To understand how fast an object is moving, we introduce the concept of speed. Speed is the rate at which an object covers distance. It is calculated by dividing the distance traveled by the time taken to travel that distance. Speed is a scalar quantity, so it only has magnitude. For instance, if you cover 100 meters in 10 seconds, your speed is 10 meters per second. Now let's dive into the concept of velocity. Velocity is a vector quantity that combines the speed of an object with its direction. It refers to the rate at which an object changes its position. Velocity is calculated by dividing the displacement by the time taken to cover that displacement. If an object moves from position A to position B in a certain time, its velocity is the displacement from A to B divided by that time. Velocity is represented by the symbol v. When an object undergoes uniform motion, meaning it covers equal distances in equal intervals of time, its velocity remains constant. However, if an object's velocity changes, it is said to undergo non-uniform or accelerated motion. This brings us to the concept of acceleration. Acceleration is the rate at which an object's velocity changes with time. It is calculated by dividing the change in velocity by the time interval over which the change occurs. Acceleration is also a vector quantity and is represented by the symbol a. Understanding motion in a straight line allows us to analyze and predict the behavior of objects moving along a single dimension. By applying mathematical equations derived from these concepts, such as the equations of motion, we can calculate unknowns, determine the time taken to cover a certain distance, or predict the final velocity of an object under acceleration.